So before I get into the code, I want to talk about the data set a little bit that I'm going to use today. I found this data set on the University of California, Irvine Machine Learning Repository website, which is a great place to go for data sets because they have quite a few. I'm using the car evaluation data set, which looks at features such as buying price, maintenance price, the number of doors, the number of seats, the size of the trunk, and the safety ranking to determine if the car is unacceptable, acceptable, good, or very good. And those last four, unacceptable, acceptable, good, and very good, are labels. So this is, again, the basic process for creating a model and predicting in scikit-learn. I'm using the Gaussian naive Bayes classifier, which assumes that our data is normally distributed. So the first thing we do is we create that estimator, and then we use that estimator to fit the model to our data, and then we can use that to predict on a new set of data. So, like I said, it's very simple. It's very three-part, basically. So now that we've done this, what does this look like? What does this mean? So here's the first 8 predicted labels up top there. As you can see, the labels come out in a numerical format, and we can compare those labels to what the labels actually are by pulling out the first 8 labels from our test data set there. And you can see that the predictor misclassified the 3rd and 4th instances there. So again, what does this mean? You know, they're just numbers. The good news is that we can transform them back into text to understand what they mean. So we can do that with the inverse transform function, which will take our numerical labels and map them back to what their text value is. So our first line up there is are the labels from the predicted labels, basically. So you can see that the estimator predicted that there would be 4 labels of unacceptable and 4 labels of acceptable, except when we compare that to what the labels actually are, you can see that the 3rd and 4th labels were misclassified as acceptable. So classification and supervised learning in general learns the relationship between the instances and the features, and is good for predicting when you know what you're looking for. So let's move on to unsupervised learning. Ooh, come on. So unsupervised learning is good when you have unlabeled data and you might have no idea what you're looking for. So you're basically pulling out patterns and relationships without knowing what's there. The 2 main kinds of unsupervised learning are clustering and